Hey guys, Dr. Brown here, and tonight we're looking at the powers of sines and cosines. What are the guidelines about performing integrals involving those powers of sine and cosine? Excuse me, in our previous video we looked at guidelines on integrals involving powers of secant and tangent. So I would encourage you to go look at that one. But tonight it's powers of sines and cosines. Are there some guidelines? Yes, there are. And they will help you formulate how to walk through these integrals. Okay, so guideline, I've just kept them in order here, but starting at the first guideline for sines and cosines, it's sixth in our guideline chart. If the sine term, the power is odd and positive, keep one of the sines and then convert everything else to cosine. And then work through the integral like that. If you keep one of the sines, obviously cosine and sine are big buddies. The derivative of cosine would be minus sine. So you keep this for the du, if you will. And it's the same concept with cosine. If we have an odd positive cosine term, keep one of the cosines and convert everything else to sine. Now if you have even powers for either sine or cosine, then convert them using sine, like sine squared is 1 minus cosine 2x over 2. Cosine squared x is 1 plus cosine 2x over 2. So you can, actually I always call that a power reduction methodology, but you can convert using those and work the problem, work the integral. So let's work on a few. I have 3 integration problems here. All right, I have the integral of sine cube x times cosine to the 4th power x. And I may be off the screen here trying to keep which is good to get me out of the picture. You don't need me in the picture. Okay, so what do I have here? I have an odd and even, like an odd sine power, even cosine. Let's take the odd positive sine power. What does it say? Keep one of the sine terms and then convert everything else to cosine. So if I pull out one of the sine terms and just say, okay, I'm going to pull this sine x dx out to the side, what does that leave me here? Sine squared x cosine to the 4th x sine x dx. Okay, well, sine squared I know is 1 minus cosine squared. So I can convert that, 1 minus cosine squared x times cosine to the 4th x sine x dx. Now if I distribute the cosine to the 4th and sine x to the inside, let's do that. I can separate that into 2 integrals if I want, and I work through it that way. All right, so the integral of all of cosine to the 4th sine x dx times 1 gives me cosine to the 4th x sine x dx minus the integral cosine squared times cosine to the 4th. Remember the rule, just add the exponents when you, so a to the m times a to the n is a to the m plus n. That's what we have here. So cosine 2 plus 4, 6x sine x dx. Okay. All right, so let's think about this. I have u equals cosine x, du equals minus sine x dx. So du over minus sine x equals dx. So what do I have here? Integral of u to the 4th, and then times sine x, and then dx I'm going to replace with du over minus, I'm going to put the negative out here, sine x. Those cancel, so I have minus the integral u to the 4th du. Okay, I have the same scenario here. I would have minus u to the sixth sine x, and then dx, or dx is du over minus, put that negative right there, minus sine x. Those cancel, so what do we have? Plus integral of u to the sixth du. So now we have increase this by 1 and divide by it, so I have 1/5 u to the fifth plus 1/7 u to the seventh, and that equals minus 1/5 u, which was cosine x, to the fifth power. And we can write it like that, or we can write it like this, plus 1/7, again, cosine x raised to the seventh power plus c. Okay, so that would be how I could take an odd power of sine, keep one of the signs, convert everything else to cosine, go through, in this case, did a u sub to work through that. Okay, so let me clean up the board and let's go down, grab us another problem. I hope everybody's been studying, expanding your mind, gaining speed. All right, we have the integral of cosine. I may just scoot over a little bit, and then if I need to work off to the side, I'll hide. I have the integral of cosine cubed x over square root of sine x dx. Now in this case, I have an odd power of cosine. So it's odd positive. Let's keep one of the cosines, convert everything else to sine. Before I do that though, or while I'm doing that, I should say, I'm going to bring up this to the numerator. So I have cosine squared x, because I'm going to take out one of those cosines. Okay, and then I'm going to bring the sine x to the minus 1/2 to the numerator. All right, now it said, since I had an odd positive, keep one of the cosine terms, convert everything else to sine. So cosine squared is 1 minus sine squared x times sine x to the negative 1/2 cosine x dx. So let's distribute this to the inside. So I have sine x raised to the negative 1/2 cosine x dx times 1. So I have the integral sine x negative 1/2 cosine x dx minus, now I have a sine squared, but I have this, a denominator here of 2, so I'm going to change this at 4 over 2. So sine, so I have the integral of sine of 4 over 2 minus 1 over 2, which gives me sine x to the 3/2 cosine x dx. Okay, well, let's work that over here. U equals sine x, du equals cosine x dx. So du divided by cosine x equals dx. So what does that give me here? If u is sine x, I have u to the minus 1/2 cosine x And then I'm going to replace dx with du over cosine x. Those cancel, so I have the integral of u to the minus 1/2 du. Okay, let's work on this side. Same scenario here. I would have minus the integral of u to the 3/2 cosine x, and then du over cosine x. Those cancel, so I have minus the integral of u to the 3/2 du. So if I increase this by 1, which is 2 over 2, so negative 1/2 plus 2 over 2 gives me to the 1/2. Divide by 1/2, which is multiplying by 2, so I end up with 2u to the 1/2 minus, same scenario here, plus 2 over 2, and it's 5 over 2. Divide by 5 over 2, and I'm multiplying by 2/5, so I have 2/5 u to the 5/2. So that equals 2u, and u was sine x. 2 sine x minus 2/5 sine x to the 5/2 plus c. Okay. All right, 2 down. Let me clean up the board. And we'll work the last one here, which is going to be an even power. Give me just a second. Okay, we have the integral of cosine to the 4th x dx. Okay, we have an even non-negative power of cosine. And I can break that into cosine squared x times cosine squared x. So let me do that. Integral cosine squared x dx. And I think I'm going to use the power reduction formula here, where cosine squared x is 1 plus cosine 2x over 2. So I would have then integral of 1 plus cosine 2x over 2 squared dx. So let's just FOIL this out. I have the 1/4. I'll just put it to the outside. Integral of 1 plus 2 cosine 2x plus cosine squared 2x dx. Well, this is going to give me a little trouble. I'll just repeat that cosine squared formulation again. So I have 1/4 the integral of 1 plus 2 cosine 2x plus 1 plus cosine 2 times the angle, but my angle is 2x. So 2 times 2x gives me 4x, and all of that's over 2. Okay, that's my integral. So I've got the integral with every one of those. So I have 1/4 integral of 1 dx, which is x, plus 1/4 times 2, which gives me 1/2, the integral of cosine 2x, plus 1/4 times 1/2, which is 1/8 the integral of this guy here. 1 plus cosine 4x dx. All right, so in this case we have u equals 2x. So I'll just write that here. U equals 2x. du equals 2 dx. du over 2 equals dx. So I have 1/4 x plus 1/2 integral of cosine u, and then du over 2, and I'm just going to put that, multiply it here as a 1/4, plus 1/8 the integral of 1 dx, which is x, plus 1/8 the integral of cosine 4x dx. So if I let t equal 4x, dt then is 4 dx. dt over 4 equals dx. So that's 1/8 the integral of cosine t dt over 4. And I'm going to put that 4 here, multiply it by times 8. That gives me the 32. So I have 1/4 x plus integral of cosine is derivative is minus sine, integral is positive sine. So plus 1/4 sine u, u was 2x, plus 1/8 x plus 1/32 integral of cosine t. So 1/30 plus 1/32. And the cosine of t is going to give me sine t, but t is 4x. All right. I have a few terms we can put together here. So 1/4 would be 2/8, 2/8 x plus 1/8 x. Well, that's 3/8 x. So I have 3/8 x plus 1/4 sine 2x plus 1/32 sine 4x plus c. So those are 3 examples on how we can utilize the powers of sine and cosine. If sine is odd positive, keep a sine, convert to everything else to cosine. If cosine's odd positive, keep a cosine, convert the remaining factors to sine. Or if they're even and non-negative, depending on if it's a sine square or cosine square, utilize the power reduction formula. Why are we doing this? Hey, we're trying to build a better tomorrow and do that through math. Keep studying, guys, and jot down these in your notebook somewhere, your phone, or however you can get to them, and start practicing then powers of secant and tangent, powers of sine and cosine. Utilize these guidelines to help you work through some difficult problems. Okay, that's all for now. Keep studying. We'll talk to you next time. Thanks.